A 10 kilogram object is shot straight up with an initial velocity of 10 meters per second from a cliff that is 60 meters high. Air resistance is 2V. Determine the velocity of the object when it hits the ground. So in this video, I'm just taking going up is positive direction. If you want to see the solution that shows going down is positive, just click the link. There's one link in the comment section. Okay, so going up is positive, so our acceleration due to gravity is now negative 9.8 meter per second squared, and we have the mass, okay, 10 kilogram. Initial velocity, that's from here, so v at 0 equals 10, and 60 meters high means initial height or position, yes, that's all, 60. This is the air resistance. In either case, up or down, the motion is modeled by the force, m times a. Force is mass times acceleration, or m dv over dt equals just the weight minus, here is 1 air resistance, we subtract that, and it comes out to be just positive, so absolute v, this is p. Now we divide both sides by m is 10, so dv over dt equals, divide by m, so cancels, g is negative 9.8 minus 2 over 10. Okay, we can just say 0. So 2 over m is 10, so 0.2 v. This is separable, but let's make it linear so that it's kind of easier. And it matches with other problems as well. So let's add 0.2 v both sides, then we get dv over dt plus 0.2 v equals negative 9.8. Okay, linear. Now we can find integrating factor mu, which is e raised to integral of this function, which is just the number, in this case 0.2 dt, that is e raised to constant, and that derivative constant is just constant t. Now we multiply this differential equation both sides by this integrating factor, and when we multiply, the left hand side automatically becomes derivative of v times integrating factor e raised to 0.2 t equals, right hand side we need to multiply negative 9.8 by this integrating factor. Next, integrate both sides, then we get v times e raised to 0.2 t equals, okay, this t forgot there, so the antiderivative, we know that when we have e raised to alpha t, okay, exponential function, integration or derivative itself, in this case we need to divide by alpha, this number. Okay, so that means we divide by 0.2, okay, 0.2, so that becomes negative 49 e raised to 0.2 t, okay, divided by 0.2, and then that comes out to be this one plus constant of integration. Now we divide both sides by this integrating factor, and we are left with just v. That's why we're going to isolate this. V is a function of t, in fact. V equals, divided by this, so this cancels out, negative 49 plus c over this, but we can move this up, and that becomes negative 0.2 t. Now we can find the value of c using initial condition. The initial velocity given in the question is 10. So using v, 0 equals 10. So using 10, we get, this is 10 when time is 0. So negative 49 plus c times e raised to is a 0, which is 1, just c. Add 49 both sides. So c equals 59. Okay, thus we got the velocity at any time. The velocity function is now negative 49 plus c is 59 e raised to negative 0.2 t. So I'm going to label equation 1 for future reference. Now we integrate both sides to find the position or the height function. The velocity is just the derivative of position. So if we integrate both sides, then end up with respect to t. So this will be just position when we integrate. Let's integrate right side. So negative 49 is 49t. And now when we do this, like exponential function itself divided by negative 0.2. So 59 divided by negative 0.2 gives 295. So it will be negative 295 e raised to negative 0.2t plus constant of integration. Now we can determine this c or d. I am using d because c is already used, or you can use c. We use the initial position, the initial height, which is 60 given in the question. So using S0 equals 60. So using 60, so this is 60 when time is 0. Negative 49 times 0, just 0, minus 295 times e raised to 0 is just 1. So 295 plus d. Now we add 295 both sides to isolate d. So d is 355. Just add 295 both sides. Now plug back here, then we get the position or height function at any time t here. Negative 49t minus 295 e raised to negative 0.2t plus d plus 355. That's equation 2. So using 1 and 2, we can answer any question about this flight and this duration of this object thrown up, vertically up. So we need to determine the velocity of the object when it hits the ground. So when it hits the ground, ground means what is the position or height? Height 0 in this case. So we set the position or height 0. So here is the position function. So we set the position 0. That from there we will be able to find the value of time, t. So pretty much to find the velocity of the object when it hits the ground, we need to figure out the time it takes to hit the ground. Okay. After we find the time, the velocity will be just given by equation 1. We just plug in here. Okay. So ground means the position 0. Okay. That is, this is 0, and we solve for t. So negative 49t minus 295 e raised to negative 0.2t plus 355 equals 0. Okay, now we got exponential term and linear term, so it cannot be solved algebraically. So we need to use a calculator or some online graphing. Okay, so just graph, and then we can make one linear equation, one exponential, and we graph and see where they intersect. So let me put this exponential to the other side, just leave linear part in the left. So this is 355, this is positive first, 355 minus 49t, and then add 295 both sides. So 295 e raised to negative 0.2t. So we're going to graph this and graph this and see where they intersect. But it's too big. Maybe we can make it easier, smaller, just scale down. 49 is the coefficient for t. Let's divide both sides by 49. Or we can divide by 355, doesn't matter, but I think 49 should be pretty good. So we got 355 over 49. Okay. That is 7.2449. 7.2449 approximately minus 49t over 49t gives us that, equals, in the right side divide is about 6.02 e raised to negative 0.2t. Now just graph this. Okay, you can use desmos.com or graphing calculator. Graph this one curve and graph this another curve and then see where they intersect. Okay, they intersect at two different places. Disregard the negative time, just consider the positive time, and then after graphing, there is some involved, so this gives us time equals 5.05. Okay, just graph this and figure out where they intersect. That's the time. So that means what we found is it takes 5.05 seconds to get to the ground. But what is the velocity when it hits the ground? So the velocity is given from equation 1. Now we replace t by 5.05. Okay, so finally, thus the velocity at the ground means velocity after 5.05. Simply plug in here in equation 1. Negative 49 plus 59 times e raised to 0.2 times, here is a t, that is 5.05, and it comes out to be negative 20, around negative 27.5, sorry. And negative makes sense because we said going up is positive, so that's meter per second. Okay, final.